Okay, this is the first look I'm getting at the Prelab. So we've got a total mass of 1.524 grams, which is a mix of potassium carbonate and sodium carbonate. So we don't know the quantities for both of those. We're asked to determine the percent composition of each, and we found out that we need to add 10 milliliters of 1 molar nitric acid, and we know that nitric acid is a strong acid, and we had 10 milliliters or 0.01 liters, and it is 1 molar, so we had 0.01 moles of acid. And we know that moles of acid is going to be equal to moles of base. In this case, each carbonate can take on 2 protons. So, first off, let's find out the molecular masses for these 2 compounds. So sodium is 23 grams per mole. So the molecular mass for sodium carbonate should be 106 grams per mole. And then the potassium carbonate is the periodic table. Let's walk over to the periodic table. Potassium is 39.1 grams per mole. .1 plus 12 plus 16 plus 16 plus 16 gives us 138.2 grams per mole. Okay, I just want to make sure those calculations were correct. So we need to set up a few equations. So we know our total mass is 1.524, and we're going to look for the percent composition. So let's do percent potassium. We'll just summarize that as K times 138.2 grams per mole plus 106 grams per mole times percent sodium. Now we don't want to say that that's going to equal anything beyond the number of moles of hydrogen, and we know we only have 1.524 grams of that, so we need to take that into account. And we do that by saying that the number of moles is going to be equal, not the number of the mass number. So before we do this step, let's look at the number of moles. So we have 0.01 moles of that. 0.01 moles is equal to 2 times the number of moles potassium plus K being potassium carbonate, plus 2 times the number of moles of sodium carbonate. And let's think about this for a moment. So this is going to be a weighted average for another number of grams. So let's scale up. We know that 1.524 grams is equal to 0.01 moles. So it's going to be 152.4 grams equal to 1 mole. And that's a weighted average of the two molarities. But that's for 1 mole of H+. And we know that each of those contributes 2. And I should probably read the rest of the problem statement, huh? Yep. So apparently I was a little bit hasty and I didn't realize that the white powder is not 100% potassium carbonate sodium carbonate, or is it? Hey, Paul.